The main topic of the day is stereochemistry, or chirality, and the key thing that I need to convey is that there are molecules who can rotate plane polarized light, and we call those molecules chiral molecules. Now that's a very strange definition for a chiral molecule, but what it essentially means is that the molecule is different in 3 dimensions. So your right hand and your left hand are different from each other in 3 dimensions. If you were to walk into a room where for whatever reason there were some disembodied hands just lying on the floor, and the lights were off, you could pick it up and you would know whether you were holding a right hand or a left hand. Because a right hand is different than a left hand. It curls differently in 3-dimensional space. That property of being different in 3-dimensional space from its mirror image is what makes something chiral. So molecules can be chiral. They can have handedness. A lot of molecules are not chiral. They are achiral. They do not have handedness. Human beings, as a rule, are not chiral. We have both a right hand and a left hand. We have a right foot and a left foot, which means that there's a plane of symmetry running right down the middle of a person that makes a person achiral overall. That in fact is a great definition for what an achiral molecule is. It has a plane of symmetry. But the reason why we care about this and the reason why we're going to go into this is because on the inside, on the molecular level, we are chiral. Our proteins are chiral, the kind of food that we eat is chiral, and so on and so forth. Drugs are usually administered as one enantiomer or the other, one version, one-handedness or the other. The right-handed version is effective. The left-handed version does nothing or is in fact dangerous. That's how most drugs are. But food is that way as well. Aspartame, one of the main artificial sweeteners in soft drinks and so on, is actually a molecule that uses the unnatural amino acids. So if you would describe the amino acids that your proteins normally have as being left-handed, then aspartame uses the right-handed version of the amino acid. And what that means is your body doesn't recognize it as food. So when you eat aspartame, all that happens is your body just passes it right through the digestive system and it doesn't register as useful calories to the body. Achiral molecules can react with chiral molecules well, but chiral molecules react differently with other chiral molecules. So the reason why we care about all of this is because of the way our bodies process chiral molecules and the way chiral molecules are going to interact with each other. Now most of the time when I'm writing up here at the board, I give the impression of being left-handed. So it looks like I'm left-handed given the way that I filmed this, but in fact I am extremely right-handed. This is my right hand, and as you can tell, I'm wearing a little wedding ring on my left hand. So I am in fact right-handed. So let me take you behind the curtain briefly. So this is the room where the magic happens. We've got a camera sitting on that table filming through this glass, and I usually stand on the far side of the glass with my back against the black backdrop. And so I'm filming through the glass, which means that you cannot necessarily read the words there. And in order to make this work, what I do is flip things in post-production. Here's the setup, the way it typically looks as I am filming. Here's what the screen looks like when I have simply recorded it, but I haven't flipped it while editing. Alright, so why did I take you behind the scenes like that? Well, because fundamentally, I need to be able to talk as though you're looking at the same thing that I am. This is my right hand. This is my left hand. If you can read the words on the screen, then I have flipped it in editing, but for the purposes of stereochemistry, what I'm going to try to do is make sure that this is readable as opposed to this. So I'm now going to make most of the words go away so that we can talk just in terms of the images that I'm going to show, and then all of the pictures that I'm going to draw, again, I'm going to try to avoid using actual text on this board, again, so that you can say, hey, when I'm looking at my right hand, I mean this one, and my left hand's this one. Alright, so the main key points I would like to make at this point, that I want to make now are essentially related to, you can tell when a molecule is chiral just when you pick it up. If you are looking at these winter gloves, you can tell which one's a right-handed glove and which one's a left-handed glove just by glancing at it. However, if I were to hold up one of these lab gloves, this is achiral. I can go ahead and put this on my left hand just fine, or alternatively, I can put one, identical, on my right hand just fine. And either way, it will work. The glove will conform to my hand because it doesn't have handedness reaction itself. This is a chiral molecule interacting with an achiral molecule, my chiral hand interacting with the achiral glove. And generally speaking, that's how achiral molecules interact with chiral ones. It doesn't affect the reactions. And so most reactions involving achiral molecules will work just fine with chiral molecules. However, that's not the way chiral molecules interacting with chiral molecules works. Here, I have a couple of baseball mitts, and you will note that the baseball mitts have handedness associated with them. This is the kind of mitt that will fit on my left hand, but won't fit on my right hand very well. This is the kind of mitt that will fit on my right hand. Well, it would if it wasn't for a 4-year-old. But because the mitts have chirality inherently, then they only fit on one particular hand. And the same idea, of course, goes with the winter gloves. If you put the winter glove on the wrong hand, it won't work the way it is designed. Although you could probably get your hands to fit in the winter gloves in a way that you really can't with one of the baseball mitts, which is why I use this example. If you are going to run a chiral reaction, it matters which enantiomer you are interacting with. It matters which handedness of the chiral reaction is taking place. Whether the hand is matched with the glove, that is something that's going to play an increasingly important role as you go further in organic chemistry.